So let's continue with elimination. So elimination means that the removal of a drug from the body. So in this case there are three basic ways through which the drug can be eliminated. The first one is through the kidney, and the second is the gut, and the third is the sweating. And there are two types of elimination. The first one is the zero order elimination, and then the next one is the first order elimination. In the zero order elimination, what happened that in this type of drug elimination, the constant amount of a drug is eliminated for unit time. So constant amount of a drug is eliminated for unit time. I have given you an example. In this example, 80 mg of a drug we have taken, and after 2 hours this 80 mg becomes 70. So it means that 10 mg has been eliminated in 2 hours. In the next 2 hours it will become 60, and then 50, and from 50 it becomes 40, right? So the time is a constant, right? And the time is constant, and the specific amount of a drug is also constant for that specific time. So at the end it means that the drug will become zero, right? 0 mg. So from the 80 to 70, 7 to 60, and 50, and then 40, and then 30, and 20, and the 10, and the time is 2 hours. So in this case the half-life of this is variable. I will talk about the half-life in the second. So in this case 10 mg is eliminated in each 2 hours, right? And next is the first order elimination. In the first order elimination, in this case constant fraction of a drug is eliminated for unit of time. So we have taken 80 mg drug, it becomes 40, and then 20, and from 20 it becomes 10 mg, and then 5, and then 2.5, and from 2.5 it becomes 1.25, and then 0.512 mg, right? In this case the half-life is a constant. Half-life is constant, right? Constant half-life, and the half time is independent on a plasma drug concentration. So most of the drugs follow the first order elimination, most of the drugs. So let me talk about a little bit about the half-life of a drug. So half-life of a drug refers to the amount of time which is required for the amount of time which is required for half of a drug dose to be metabolized, or we can simply we can say that the time period at which plasma drug concentration will become half. So the time period at which plasma drug concentration become a half. For example, we have taken 10 mg drug, right, and this 10 mg become 5 mg, right? But the time at which the plasma drug concentration become half, so the time it takes, for example, 1 hour. So 1 hour is the half-life of this particular drug, because we have taken a 10 mg drug, right, and this 10 mg become 5 mg, but the time at which it become 5 mg was 1 hour. So this 1 hour is the half-life of this particular drug. Next is the steady state. So steady state is very simple. Steady state means that the rate in is equal to rate out. So what is rate? I will tell you. This is known as the steady state. इसका मतलब ये है कि मतलब हम जितना ड्रग ले रहे हैं, ठीक है, और उतना ही ड्रग निकल रहा है, उसका जितना एलिमिनेशन हो रहा है, ठीक है, तो इसको कहते हैं स्टेडी स्टेट, ठीक है। The steady state can be achieved after 6 to 7 half of that time, right? It should not be achieved so early, and the steady state can be achieved with early loading dose. So rate in and the rate out is known as a steady state. For example, one capsule of webromycin, take one capsule. For example, we take of a webromycin which is 100 mg, okay, or doxycycline or any antibiotics, and the first dose we take 2 capsule, right? In the first time we take 2 capsules. So this is loading dose, and the plasma concentration will become 200, right, mg. We take one capsule of this particular drug is 100 mg, but in the first dose we take 2 capsule, so 100 plus 100 become 200 mg. Then after half of this 100, we take second dose, right? So 200, then later it become half 100, right, mg. So in the second dose, for example, we take 100 capsule, 100 mg capsules plus 100 mg plasma drug concentration, this one, it will become 200 mg. Then after half of this time it will become 100. So we are taking one capsule 100, and then in the first dose we take 2 capsule, it become 200, right? And half of this is removed, so 100 left, and in the second time we take 100, and this 100 plus the remaining 100, it become 200, right? So this is the first dose we take 200, and now we have 200. So this is known as the steady state.